This is the top of the second page, and if you draw these three graphs at the top, these three systems, the first one, it turns out these equations give you the exact same line. So it's the same line twice is what that says. One line goes right on top of the other. And that means that whatever works as a solution in one equation also works in the other. So we would say that that system has infinitely many solutions. The next picture, if you draw these two graphs, you get parallel lines, so there's no point common to both, and that system is not going to have any solution. That system has no solution. And lastly, the thing that more typically happens is you draw both graphs and you get one point that they share. And here the common point is 7 for x, 0 for y, and you have that one solution. So some vocabulary you're going to notice in the textbook is the first kind where one line's on top of the other. That's called a dependent system, where the lines are parallel and there's no solution. That's known as an inconsistent system. And the third, the more normal one, is known as an independent system. I'm going to do one more on this page. I'm going to do the one at the very bottom. And let's see if I can get this. There we go. Just a little bit. So if we graph these two equations over here, we should be able to get a solution for the system. Top one is the type where we'll plug in 0 for x and solve for y to get the y-intercept first. That says 2y equals 10, so y equals 10 divided by 2. The y-intercept is 5. And plug in 0 for y, and then it says 5x equals 10, so 10 divided by 5 is 2, x-intercept is 2. So I see the pattern here is down 5 over 2. Let me do that again. Down 5 boxes over 2. There's the graph of 5x plus 2y equals 10. The second equation is in the convenient slope-intercept form. We'll start at the y-intercept of minus 4. And the slope is negative 1 over 4. So I go down 1 over 4, down 1 over 4, or up 1 and to the left 4. There's the graph for the second equation. And now we just have to check what are the x and y values of the point where they intersect. 0, 1, 2, 3, 4. So it's 4 for x. And 0, 1, 2, 3, 4, 5, negative 5 for y. This would be the solution. Oops, I'm sorry, I didn't realize that was off the screen. 4, negative 5 is the solution for this system. Again, the main thing to notice is you just graph both equations, and if they intersect at a single point, the x and y for that point is the solution. And going back to the top one more time, if you get one graph right on top of the other, that means there's infinitely many solutions, and that's called a dependent system. If you get parallel lines, that means there's no solution. That's known as an inconsistent system. And if you get a single point of intersection, that x and y value from that point is the solution. That's known as an independent system. Okay, thank you.